Let's talk coronavirus. So here's a bunch of stuff I learned over the last couple of days trying to research this thing. I know there's been a lot of give and take and back and forth and disagreements and panic and all that crap, but that's okay. Here's what I've learned and kind of summarize. I did a bunch of research yesterday instead of working, really. I should have been working, and here's what I've come up with. So, first thing, under 30. If you're under 30, you're in good shape. So it seems like the virus cannot kill you really if you're under 30. Now, if you're under 30 and you have other medical conditions or something like that, as everybody's been saying, then you're at risk. But if you're kind of a normal under 30 young person, then youth is on your side and you'll be spared. Now, luckily, this is especially relevant for my nieces and nephews. You're spared if you're a kid. It seems like really it doesn't kill any healthy children. No healthy children have died in the creation of this COVID-19. So COVID-19 is child friendly, which is one of the few good things about this damn thing. And that's very good news for people who are panicking. Relax, your child is not going to kill anybody. Now your child could be a vector for transmission, so you still want to avoid having your child play with other children, or you don't want to kiss your child or whatever after they've been to school. It's kind of a problem, but in general, children are spared, so yay. All right, so a few things. First of all, COVID-19 is the name of the disease. Technically, I know it's not the name of the virus. The name of the virus is SARS-CoV-2, I believe. But this is kind of easier to say, COVID-19. All right, so let's talk a little bit about what the virus is, first of all. So the virus is not the flu, so don't think of this as the flu. It's not, flu plus plus. It's more like cold plus plus, like a standard cold, but extra evil. And so it's a coronavirus, which means it's part of the coronavirus family. It's a family of viruses that cause various ailments, and there's a bunch of coronaviruses that circulate in our society anyway today. I think 4 of them that cause the common cold. There's other things that cause the common cold, but 4 of them do. So it's not anything new. It's just it's more clever of a virus. Okay, it's more evil. It's found some tricks evolutionarily to spread and cause people to buy toilet paper, apparently. So, all right. So it's not the flu. It's more of like a coronavirus, and that's the best way to kind of study it. I think if you want to study it by analogy, you want to compare it to coronavirus. Let me talk a little bit about the mechanism of how this thing infects the cell. Now, this is very interesting. It's a huge topic. Essentially, it is microbiology, but let's just make it simple here and represent a virus as this thing. So I'm just going to represent a virus as this shell. You've got this outer shell over here made of fat, essentially. It's lipids, but essentially it's fat. And then you've got some RNA on the inside. So this is code. And that's it. That's all a virus is. It's a packaged up piece of code that does bad things. So we'll talk about how this does in a second. But the capsule is important here, because if you shred the capsule, if you kill this capsule, or dissolve it by, say, alcohol or soap or other lipid-soluble stuff, you kill the virus in the sense that this code by itself over here can't do anything. You need this outer capsule. Why? Because the outer capsule is what attaches to a human cell. And so this is not the scale, obviously. This is many thousands of times smaller than a human cell. But you attach to little receptors on the cell wall using this capsule, and then the code gets injected. Okay? So let's talk a little bit how this virus replicates. This is any virus that replicates. It's really just amazing from a code perspective. So skipping over all the medical jargon, essentially what you have in the cell, you've got your nucleus, and your nucleus has its own code. Let's write, little pieces of DNA, actually a lot of DNA, coiled up inside the nucleus. Every now and then, which is really all the time, a piece of that code gets copied out into the cytoplasm, okay, so that it can be read and something happens with that code. Okay, so think of it as photocopying a page out of a cookbook for a recipe. So let's say the recipe says beef stroganoff. You copy that page of beef stroganoff into the outside into the cytoplasm. It's called outside of the nucleus, and then there's this little cool machinery. I think it's called DNA polymerase or whatever. They attach to this and kind of read it and execute it, or read the recipe and produce as output. A long and twisted and complicated chemical. We call them enzymes or proteins, but those then go along and do something else in the cell, or go outside the cell to do stuff like hormones or whatever. That's it. That's basically how life works. So how does the virus mess life up? Well, the virus attaches via this capsule, as mentioned, into a receptor, some kind of receptor for the COVID virus. This is, I think it's the ACE2 receptors, which is obviously a target for research here. It attaches to that, and what happens is that essentially the shell bypasses the receptor security, and the shell dissolves, and what happens is this piece of code gets injected into the cytoplasm. Let's delete this real quick. So really what happens, this little piece of code just gets parachuted into the cytoplasm. So it's over here. So now you've got this DNA polymerase machine, which will glom onto this and execute the recipe again. It doesn't know. It has no brain. So it's just a piece of code that's compatible enough that it will glom onto this over here and execute the code again. Well, now though, what's the output of this? Well, the output of the viral code is a evil, let's say, protein. It's an evil machine, a little thing that looks like a specific shape. And that thing actually goes back to the piece of RNA that has been floating around and reads it again and again backwards. And when it reads it backwards, the code is a little bit different. And what that does is the output of that code is actually little virus particles, which is the magic sauce for all of this. So that's this is a very bad zoom out of this thing over here. So essentially, you just get this thing where now there's this evil machine replicating virus. It's just pumping out viruses inside the cell, and it will produce thousands, if not millions, within one cell. And then finally, the cell decides, you know what, I'm dying, or something triggers a cell death, and the cell dies, and the wall breaks, and all the virus kind of leaks out. And now you've got virus everywhere around the cell, and it goes on to infect other cells. Repeat until the person dies. Okay, so it's pretty simple, really, but this is evolution at its finest. And we could talk about evolution later and how that affects viral behavior. So let's talk a little bit about how this thing kills you. So it's very clear at this point that what actually kills you from COVID-19 is something called essentially ARDS, which is acute respiratory distress syndrome. It's just basically your lungs. Let's try to draw some lungs. Here's your basic lungs drawing. Your lungs are just a series of tubes that, just like the internet, that eventually branch out into leaves, but the leaves look like little sacs of air. These are called air sacs, or one of the most horrible medical names, alveoli. God, what an awful name. Alveoli are these little air sacs, and if the virus gets to these, okay, and you've got about, I believe it was 150 million of them. You've got a lot of these tiny air sacs. If the virus gets to them, then you're in trouble. What do the air sacs do? Well, the air sac is where the gas exchange happens. So let's zoom into the air sac real quick. So here's kind of the air sacs. It's got this interesting structure, but essentially what you have is a place for carbon dioxide to leave and oxygen to come in. So you've got blood vessels running inside this, I believe, like that. And, you've got veins and arteries, and you've got oxygen going in. So you got O2 comes in, and then carbon dioxide gets exhaled out or gets exchanged out, and then you exhale it. That's it. And so with coronavirus, if it gets to this level, and I think that's part of the reason why younger people have a better chance of surviving, is that the virus doesn't get deep enough into their lungs. It gets stopped higher up in the lungs, somewhere, in the bronchial tubes. That's how you get bronchitis. It's the bronchial tubes. It's kind of like the highways of your lungs. If those get infected, it's less serious of an issue. If you get down all the way to the alveoli, then you've got a situation where you have inflammation here. So inflammation will cause kind of fluid to accumulate here, and the walls get thicker, so it's harder to breathe. It's just a simple matter of oxygen can't get in and carbon dioxide can't get out as easily. It's really, this guy is the critical, obviously, for life, and so you can't get enough oxygen. And so in that case, that's when you need to get put on a ventilator, as they call it. It's basically a machine that forces oxygen at a high pressure so it can diffuse into your blood. We need those ventilators, obviously. This is the ER. If you go to the ER for this is what they do. They put you in intensive care, and they put you on a ventilator if you're not able to breathe enough oxygen. So I believe China is, I like how China's in red there. China is donating to Italy a bunch of ventilators, machines, because they obviously need it. So other than, if you can avoid pneumonia from this virus, then you're in good shape. So that's key. So keep your lungs healthy. Obviously, it's kind of intuitive how you keep your lungs healthy. Don't smoke and blah, 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 all the stuff that you're used to. But one good way is to increase your cardio ability. Generally, doing cardio exercise improves your lungs capacity, or your VO2 max. That's how much volume of oxygen you can inhale with one inhale. And the higher that is, the less likely you are to die from pneumonia. But it's not going to be an effective strategy now to go out and become a marathon runner. You just try to keep your lungs healthy. Okay, so another thing, let's talk about some interesting research that's happening. So one of the cool research I think happening in South Korea and China right now is something called zinc ionophores. So zinc, that's the chemical symbol for zinc. Zinc is a necessary chemical for all of life, but usually it has a hard time, because it's an ion. It's actually got a +2 charge. It has a hard time crossing the cell membrane, getting into the cell. Now, if you remember that evil machinery that we talked about before, that thing, zinc, tends to disrupt its machinery. It tends to disrupt its action. So that's very good. If we can get zinc inside the cell, you can actually slow down the replication rate of the virus quite a bit. And that's a very good thing. If we can get zinc inside here, that's a very, very good thing. And the problem is, though, that we can't get zinc easily without something shuttling zinc across the cell membrane. Well, for that, you need something called a ionophore. Kind of a cool word. Ionophore just means something that allows ions to pass into the cell, to go past the cell membrane. So we looked around, or Chinese researchers looked around. What is a good ionophore generally for coronaviruses? It's a malaria medication called chloroquine. Chloroquine, I believe, or chloroquine. I don't know how to pronounce it. But this thing shuttles zinc inside the cell and can dramatically improve, at least for previous coronaviruses, can dramatically improve outcome. So this is cool. I'm watching this pretty closely. This is, I think, one of the things that could happen that could really help us in this crazy fight. Now, don't go out and buy zinc and OD on it, because zinc can kill you, can damage your kidneys and liver if you eat too much, because it's a metal, so don't do that. The trick is to get zinc from outside your cells inside your cells, and for that you need something like you need an ionophore, chloroquine, or something else. They're actively testing this right now. Okay, so it'll be months before we have anything, though, because of regulations and all that. You want to make sure it's safe before you prescribe some medication. Um, in terms of vaccine is not looking too fast, unfortunately. So everything I've heard from vaccines, it's 12 to 18 months for a vaccine. Why? Because vaccines have to be tested for a long time to check for side effects. You have to go through clinical trials, and those are not fast at all. So sorry, those are the process. Kind of annoying that this is the process that we have to stick to it, but it makes sense. You don't want to create a vaccine that you find out, oh, actually it gives you kidney damage, but it cures you of coronavirus, but kills you of kidney disease in a year. That's a no-go. So by design, they have to be long-term studies on vaccines, and so it's going to be a while before we get vaccinations for this. Okay. Now, in terms of how deadly this virus is, so I've heard a bunch of percentages. It seems like, at least from my perspective, it's definitely less than 2%. So less than 2% of the people that get it die, which I guess is pretty good. I compare that to the flu, though. The flu is around, I believe, 0.1%. So 0.1% of the people that get the flu will die from it. This is, 20 times as bad if it's 2%. So that's pretty serious, but not, panic and buy all the toilet paper in the goddamn world serious, but it's somewhat serious. I've heard an expert I trust pretty well. He had an estimate of 0.6%. That looks much better than 2%. It's still, 6 times as bad as the flu. What does that mean in terms of how you should think about this? I mean, it's like, if I tell you to be 6 times as scared, what do? Do you just go out 6 times less, 1 time a week instead of 6 times a week? I don't know. It's hard to quantify these things, but it's not terrible, but it's definitely worse than the flu. So, we should adjust our panic levels and behavior for that. So another thing that you've probably seen over and over and over people talking about is flattening the curve. So this is the epidemic curve. This basic idea that if you get you could have the situation where a lot of people get sick very fast, but since they get sick, they either die or get better, then, you get rid of the infection pretty quickly. It's over. And this would be great if we had the capacity to deal with this, but obviously we can't. So it's like, the medical system and the stock market and other systems have only a certain kind of capacity for having a number of sick people at a time. In the United States, it turns out it's pretty bad, actually. It's worse than most developing countries or developed countries. So, this area over here will be patients and demand for medical stuff that is unmet. So that's bad. You want to get rid of this. So what you do is you try to spread out the infection so that it's still the same amount of people that get infected, perhaps, but over a much longer period of time. And the idea here is that even with this, if you flatten it high enough, then at some point, you might have a vaccine or a cure, hopefully in like a year or something. So that way you can avoid this many people getting sick or dying. So that's also a cool effect. But really the main effect is that you don't overwhelm the medical system. So you want to stay under this line, the threshold of what you can handle. Italy doesn't have enough ICU beds. The United States definitely does not have enough ICU beds. If we had a situation like Italy, it would be pretty screwed. And so one of the main things that is effective against this, as I've read, I was kind of skeptical, honestly, but apparently school closures. Shutting down schools is good not for whatever reason, for this reason, but it seems to be more effective than other measures. Banning travel is not as good. School closure is very good, probably because children are a nice vector for transmission, and they don't really understand washing your hands all the time and not hugging people and blah, blah, blah. So school closures is a good thing to flatten the curve, as are other measures like improved testing and whatnot. All right, guys, so that's all I have for now. I'll keep you up to date, especially on anything that's zinc ionophore related. In general, though, don't panic too much. It doesn't seem like a huge deal. Just worry about the elderly and people who are at risk, like damaged immune systems and whatnot. All right, bye for now.